Hello folks, and welcome to another episode of Copter Air Crash Investigation. I'm reviewing a problem which happened to Andres Azarte, I hope I'm pronouncing that right, on the APM Pixel Controllers group. He had his copter doing an auto mission and it crashed toward the end. Sort of a hard landing slash slow crash. As you can see here, it gets to the end of the waypoint and then seems to really rapidly lose altitude until it ends up in the bushes. So I had a look at the data flash logs to try and work out what's going on. First thing I looked at is I ran an auto analysis, and that came up with everything being fine. So then I started looking at the logs proper. If we look at the voltage, the VCC voltage is fine, and also the pack voltage is fine. In fact, it's really consistent, which, I don't know, he does seem to have two very large packs running it, so it could be normal. But there doesn't seem to be any problems with, board voltage or brownouts or anything like that I can see. I also looked at things like GPS, and that's all fine. If we have a look at the flight mechanical failure information, you can see here that the yellow line is the reported altitude, so that's what the copter's current altitude actually is, and then the orange line is the desired altitude. Now, because of the way copter works, generally it's not going to command more or less than it's capable of really achieving. So it's limited by rate. So if you're at 10 meters altitude, the copter isn't going to suddenly say, give me 100 meters. It's going to say, I want to go from 10 meters to 100 meters, so it'll say, give me 20, and then give me 30, and then give me 40, and it will slowly gain altitude. And you can see this happening at the start of the flight. So here, once again, the orange line is the desired altitude, and the yellow line is the actual altitude, and they're pretty much lined up. So it slowly ramps up the altitude till it gets to 50 meters, which I'm guessing is the programmed flight altitude, and then it stays there for the rest of the flight. What happens at the end is interesting. The actual altitude starts to drop. So you can see here the altitude dips and dips and dips, and the desired altitude also starts to dip, likely because of that cap on how quickly it's going to request a change in altitude. So the copter is saying, the flight controller is saying, gain altitude, and clearly it's not happening. So if we look at the amount of throttle being sent by the flight controller versus things like altitude and so forth, we can see here that the copter is sending full throttle to try and gain altitude during this whole period. We can see, if we have a look here, there's some periods where it drops the altitude because it's trying to maintain that 50 meters. And then as soon as it starts to dip, it's at 100% throttle. It's trying to send full power to the motors. So I'm leaning toward this being either a mechanical failure, so something whereby the motors aren't producing as much lift as they should be, or the copter itself is overburdened, and maybe there's a strong wind, and therefore the amount of lift being generated isn't sufficient to keep the copter in the air, or I'm leaning toward this being some kind of voltage issue or componentry failure that isn't showing up in the log. What's interesting is, if we have a look at the desired altitude again, so I'll just clear this log and regenerate it. Now, this is what's really curious to me. It looks like a brownout, but that's not what the voltages support. What you can see here is the copter trying to compensate for the altitude loss, and then it hits this time code at about 38 meters and then drops to absolute zero. So there's no data between this point and this point. It's just a single drop to zero. So the desired altitude is now 0, And what's also interesting is that the desired roll and pitch also goes to 0. So if I zoom in again here, the green line and the pink line are the desired roll and pitch. So that's the attitude the copter wants to have, and then the red line is the actual roll, and the blue line is the actual pitch. And what's interesting is that it's still logging this information, it's still logging that the copter is moving around, but the desired roll and pitch go to absolute 0 again, and they don't change from that point, they just stay at absolute 0. So you've got the desired altitude drops to 0, the desired roll and desired pitch all drop to 0. It's almost like the flight computer just gives up and sets everything to 0, which is basically textbook brownout. There are brownouts where you can have IMU data and roll and pitch information still gets logged, but one part of the flight computer fails, and so you don't actually have the flight computer telling the drone to do anything anymore. It just sort of keeps doing whatever it was doing at the point of failure, which I guess at this point is, giving a certain amount of throttle, and that's it. So I would be looking at things like the power module, looking at the voltages that the batteries are giving out, looking at things like the flight computer itself. If it's a clone flight computer or something like that, it's possible that it's faulty, because it's a very weird problem that you've got here, where it's like a brownout, but there is no brownout. So I can't really explain it. Sorry I can't be of more help, but I hope that at least gives you some information to work on. The frustrating thing is that everything seems to be fine, and yet it still fell out of the sky. Realistically, the only two things that can reduce a copter's ability to produce lift are mechanical failure and power. If it was a mechanical failure alone, you would think that the copter would continue to try and fly, i.e. the desired altitude would continue, this orange line would continue to be above the yellow line right until the point of crash. That would indicate that something went wrong with the motors or the ESCs or whatever, or it's generating not enough lift. But it doesn't. It's like, my thinking is that there is some kind of power drop which causes the copter to lose lift, and then once the copter loses lift, of course the flight computer then crashes after that point. That's the only thing I can think of. So I hope that helps. Obviously I'm not the be-all and end-all, so if anyone else out there has some thoughts on this, I'll post the link to the log files below, and hopefully we can get to the bottom of it. Thanks for watching. If you enjoyed this, please leave a comment, let me know, and I'll do some more of these videos looking at troubleshooting flight problems and so forth.